So I'm going to talk about a new district heating and cooling architecture, sorry, named the fifth generation of district heating and cooling. It's a concept that have been developed within a European funded project named D2Grid. I will attempt to link this concept of DHC to the topics of industrial excess heat and ask the question, is it a good way to valorize low temperature industrial excess heat? So before showing the concept, maybe just 1 minute on what is GreenFlex. So GreenFlex is a consulting company, but not only. So we help clients, industrial, but not only, to build roadmap and strategies on energy and environmental issues. And we also help the clients to implement the projects. So my department is leading some technical studies and deploy some projects on energy efficiency, decarbonization, renewable energy, and district heating and cooling networks. So we are not only a consulting company, we are also developing projects, and in particular, excess heat valorization in industry. So why the D2Grid project is born? So it was a fact that in Europe, 50% of the global energy consumption is related to heating and cooling needs, and the share of the global energy consumption that comes from renewables accounts for 23% in 2024. And the D2Grid project also highlights that the share of renewable energies in energy consumption for heating and cooling in the 5 northwestern European countries that has been involved in the D2Grid projects accounts for only 8%. So it's quite low. These countries involved in the project was France, Germany, UK, before Brexit, Belgium, and the Netherlands. And so the main objective was to increase the share of renewable energies by accelerating the deployment of demand-driven smart grids, providing low temperature heating and cooling to cities in Northwest Europe. So what is a conventional heating network, and what is the concept, the big definition of fifth generation district heating and cooling network? So I think you are all aware of what is a conventional heating network, but I will be short. So you have a centralized facility that will produce high temperature heat to the network, and the network will be connected to various end users. Basically, the facilities are powered with very high temperature vectors, such as gas, oil, coal, and now more and more biomass. But biomass is renewable, but maybe that there will not be enough biomass for every need. So we need to prioritize the use of biomass for energy. The heating and cooling networks are usually independent. So the concepts that have been developed and defined within D2Grid project was the fifth generation. So The main concept is that you have a low temperature loop, water loop, and that loop can be fed with a low temperature source. So it can be low temperature geothermal energy. It can be low temperature waste heat. It can be also low temperature heat from wastewater treatment plants. And then the end users or blocks of end users are connected to this low temperature loop with active substations. So it's the energy plants in this case are decentralized, and thanks to heat pump, you can produce heat and cold, and you can produce heat and cold at the same time. And that allows the exchange of energy between end users that might be complementary. And I will show some example after. Okay, so the 5 principles and the 5 advantages of this type of networks is that you can maximize the exchanges of energy, the complementarity between end user, because with a thermodynamic machine, when you produce cold, you produce also heat. And so at a neighborhood or at a building level, you can have exchange of energy. And so while some users need to cool down their process, for example, the retail industry, data centers, other need heating. So you have complementary. This is the first principle. The second one is that with a low temperature network, you can valorize low temperature sources. It can be renewable, but it can be also recovered. And it's a way to move away also from fossil fuels and to prioritize lower quality thermal energy sources. And this is very important from an exergetic point of view. Heating up buildings that requires 20 degrees, it makes no sense to supply it with for example, in Paris, it's high temperature steam. And so the projects think that it's better to keep these precious resources for higher needs, for example, in industry or other applications. The third principle is to decentralize the energy production to fit the demand. And so if a building, for example, is efficient with a good insulation and equipped with, let's say, a floor heating system, the building will require only, let's say, 40 or 50 degrees to heat up the building. And so with that heating, with this DHC, the heat pump is able to produce the heat at the right temperature level and not above. And so this is this will enhance the COP of the heat pump, the COP. The fourth principle is that you have mutual benefits between the electricity network and your district heating and cooling network. Because an electricity network will have some difficulties to store the electricity. And so in this case, you can use the storability of the heat or the cold to give flexibility to the electricity network. For example, when it's 2 p.m. and the sun is shining, you will produce a lot of electricity from solar panel. The electricity will be very cheap, let's say. And so you will be able to store heat during the afternoon. and then discharge it to supply heat at 7 p.m. or 8 p.m. when the electricity demand is very high. And finally, so it's also a way to prioritize local energy sources. So first, to reduce losses during transport, to stimulate the local economy, and to increase the regional resilience. So this is the 5 principle, and to be more concrete, so D2Bits projects aim to help the development of 5 pilot sites across Europe, 1 in each country. In France, it was the pilot of Paris-Saclay. Paris-Saclay is a new neighborhood dedicated to research, innovation, and so on. And so the buildings was new, and the district heating and cooling was also new. And to be innovative and to be more sustainable, they have decided to have a DHC close to the 5G, the 5th generation concept. So how it works. So you have the low temperature loop in green. It's around 25 or 30 or 35 degrees. You have also it's a centralized plant working with geothermal energy, but not high temperature geothermal energy. The extraction well comes out at 35 degrees, and then it's re-inject in the soil. And so the main part of the heating network is this decentralized plants with short-term thermal storage, and they will produce the heating energy at the right temperature level. And you can also connect other low temperature sources. So this is the case for a data center that needs to be cooled down, and so they produced it produce heat for the low temperature network. And so, of course, to balance all the needs, they also have installed a gas boiler and a cooling tower to make sure that it can provide enough energy at every hour in a year. Okay, and yeah, so just to conclude, to be honest, the D2Grid projects and our work was not really related to industrial excess heat. However, it is a way to supply a low temperature heat, but we didn't study it in one of the pilot sites. But we have at GreenFlex encountered this case with pulp and paper industry in east of France. The pulp and paper plant was rejecting a lot of low temperature heating around 30 degrees. And the question was how to valorize it, because the process needed very high temperature, steam, in fact. So one of the projects studied was to connect to the next city with a low temperature network with pipes. It was around 3 kilometers of pipes to connect to the city, and to develop a new DHC in the city based on the 5th generation district and cooling. So you can of course, it's suitable. The 5th generation district heating and cooling is suitable with low temperature waste heat. And so I put a plot. So it's for France, but it's the industrial excess heat potential for different temperature level. And as you can see, the global potential for very low temperature heat is quite big. It's around 30 terawatt hour in France. So I think that there is a big potential for this, but however, there is some implementation challenges that need to be taken into account. The first one is that fifth generation district heating and cooling is more suitable with new networks, and it's difficult to downgrade the level of temperature of an existing network. So this is the big challenge. It's for it's better for new networks. And also one of the challenges that industrial sites can be located far from heating networks, and that connected the factory with the city. You need to invest in the heat distribution, and that have a cost that can be a constraint for the implementation of the project. So yeah, this needs to be taken into account. Thank you.